Lesson 18, graphing cubic, square root, and cube root functions. The important things you have to remember from this lesson are the following. What functions do these graphs represent? What is this? Should be y equals square root of x. What is this one? This one is y equals x cubed. What is this one? Y equals the cube root of x. What is this one? X squared, yes. This one is y equals x squared. What happens when you try y equals the square root of negative 25? You get an error, that's right. What is the cube root of negative 729? In your calculator, if you want to do this one, you have to do the following. Negative 729 in parentheses, caret, parentheses, 1 divided by 3. The answer to this is negative 9. Lesson 19, translating functions. Here are the important items you have to remember from that. And also, Lesson 20, stretching and shrinking graphs of functions. We're going to combine those into 2 on the review. Describe the translations that have occurred to arrive at the following. This one has been stretched vertically by a factor of 3. It goes to the right 2, and it goes up 4. Describe the translations that have occurred to arrive at y equals a negative 2 times the absolute value of x plus 5, close the brackets, and then minus 1. It's gone down how many? Down 1, yeah, we can say that it's gone down 1. It's gone to the left 5. It's not going to shrink, it's going to stretch. Stretch by a factor of 2. And then what? It is reflected across the x-axis. The red is y equals x squared, and if you change colors here, if you do a vertical stretch by an integer factor, it's going to look like that. If you have a factor of 1/2, 1/3, 1/4, and so on, then it's going to look like this. That would be a stretch, that would be a shrink in terms of vertical. Describe what has happened to the parent function to get to this. Stretch by 2. Left 3. Does it go to the left 3? It goes to the left 6, right. Then what? Down 3. Anything else? That's it. Stretched vertically by a factor of 2, left 6, down 3. What has happened to this problem, to the parent function to arrive at this? vertical stretch by a factor of 4, up 5, right 2, and reflected across the x-axis. That is right. What has happened to the parent function in order to get to this? Vertical stretch of 3 by a factor of 3. Right 1, down 4. Is that it? That is it. That's everything. What has happened to get to this? It's gone up 3, yeah. And that's it. Up 3. Lesson 21, transformations of the quadratic parent function. Write y equals 2x squared plus 8x minus 15 in completed square form and describe what has happened to y equals x squared. So here it is on notebook paper. We have to complete the square. Alright, so we have to get these two grouped together, and we're going to factor out 2 and be left with x squared plus 4x and leave a space. Find half of the middle term. Half of 4 is 2. And then you square 2 to get 4. So we end up with an addition of 4 in this spot, but we did not add 4 to that side of the equation. What we've really done is 4 times 2, so we've added 8. So if we added 8 there, then we have to subtract 8 out here. And putting it in the completed square form, 2 times the quantity, variable, sign from the middle, half of the middle term, close quantity and square it. On the outside we have minus 23. And the directions say to describe what has happened to the parent function in order to arrive at this. And that is a vertical stretch by a factor of 2. That comes from here. It has moved to the left 2. And then it's gone down 23. Lesson 22, comparing quadratic, square root, and cube root functions represented in different ways. We have student 1 and student 2. Student 1 is represented by a graph indicated by the number of hours studied and the corresponding grade on a test. Student 2 here has a function, y equals 2x plus 3. If both students studied for 3/4 of an hour, then who had the highest score? And what were both scores? Well, over here we can find 3/4 of an hour. Here is the x-axis. Here is 1. Stop me when I get to 3/4 of an hour with this hand. Right there, that is 3/4 of an hour. So we're going to go straight up from that spot up to here and then go over this way. Let's see if we can figure out what that grade is. We have 75 here, and this is 90. What is the difference between 75 and 90? 15. This mark is approximately what distance between these two? Halfway. What is half of 15? 7.5. So what is the grade? (82.5), right. 82.5. They studied for 3/4 of an hour and came back with an 82.5 on their test. So let's go over here. Here is student 2. Student 2 also studied 3/4 of an hour. So let's find 3/4 in here with x. 2 times 3/4 is 6/4. And then we're going to have to simplify here. 6/4 is the same as 3/2. And 3/2 is the same as 1.5. So y comes out to be 4.5. But is 4.5 their grade? No, 4.5 is not their grade. We're going to have to come over here and see what this represents. You can do 4.5 on that, or like if you put in 3/4 there in black, if you put in 3/4 you come back with 4.5. So 3/4 is still right here on this graph. You have two different ways that you can go through and find this. You can use this item here that we just found, 4.5, and go 4.5 unit markings up. Or we can graph the equation, which we've graphed multiple times previously in the school year. 2x plus 3. So if it starts out at 3, if we start out at 3, we have a y-intercept of 3. We get the 3 from the end of the equation. So we come over here and we go 1, 2, 3 and make a dot there. The slope is 2. That means you go up 2 and then over 1. So we're going to go up 2 over 1, make a dot. Up 2 over 1, up 2 over 1, up 2 over 1. 3/4. Here it is. It's in the same spot. I'm tracing over it in black. Studied for 3/4 of an hour, and that's what they came back with. Remember what the value was for y when we plugged in 3/4. It was 4.5. Look at where that's at on the graph. 1, 2, 3, 4.5. So you can mark it off that way, or you can graph it. What grade is that? $67.5. Who had the higher grade? Student 1 had an 82.5, studying 3/4 of an hour. The other one had 67.5. Lesson 23, Modeling with Quadratic Functions. A man stands on a cliff 100 feet high and throws a ball up into the air with an initial velocity of 75 feet per second. You have 3 things to answer from this. What height did the ball reach? How long did it take to reach that height? How long did it take the ball to hit the ground? It is feet per second. That is what you have to know first, because you have 2 functions you can use. One that has negative 4.9 to start with, the other that has negative 16. This one is going to be negative 16. So we're going to start off with the following. We're going to have y equals negative 16t squared. Our initial velocity is 75 feet per second. So we come in here and we put in 75t. And then his initial height is 100. So we're going to come back over here and take care of plus 100. If you want all of the important information from a problem like this, then you're going to have to complete the square. So we'll start here by grouping these two together. taking out the negative 16, and be left with t squared minus 75 over 16, leaving a space, and then plus 100. You need half of the middle term. The middle term should have a t beside it there. The middle term is a fraction. When you find half of a fraction, you double what? The denominator. Yeah, so now we end up with 75 over 32. And we have to square that. So on your calculator, 75 squared is 5625. Looks like I'll have to zoom in here a little bit. I didn't leave enough room. Plus 5625. And then over 32 squared, 1024. We did not add 5625 over 1024 to this equation. What we have done is negative 16 times 5625 over 1024. That means that negative is going to mean we subtracted a quantity. So we're going to have to add something on the outside here, and that something is 16 times 5625, which is 90,000, and we have to put it over the 1024. So I'll have to zoom in here. 90,000 over 1024. Okay, so now we have to put it in the proper form. We'll come down here and do y equals negative 16 times the quantity squared of your t, sign from the middle, half of the middle term. Close quantity, square that. On the outside, we're going to have to find out what 90,000 divided by 1024 is, and then add to that 100. And it comes out to be a positive 187.89. And with that, we have the information we need, except we could probably do one more thing. 75 over 32. 75 over 32 is 2.34. So we will do that and leave everything else the same. So now we can take out our vertex, which is going to be a maximum point, 2.34 and 187.89. This represents the number of seconds it took to reach the maximum height. This is the maximum height in feet. And then you'll have a third thing that you have to find, which you can do by solving for the two solutions of the equation. We have to find the time that it took the ball to hit the ground when it was coming down. If we want to do that, we can use this here, this exact same thing. And we can just set it equal to 0. So negative 16 times the quantity squared of t minus 34, close the quantity, and plus 187.89, and set that equal to 0. We are going to move the 187.89 to the right hand side, change the sign. Divide by negative 16. And then find the square root of both sides. That's going to leave me with this. If I do the square root of both sides, I'm left with this. And then I'm going to have square root of that quantity, so I'm going to do that in the calculator. Double negative, so it comes out to be positive 187.89 divided by 16. And it comes out to be 3.43. You have two values of t that you can find. One is with, remember that's plus or minus, 3.43. One is with a positive 3.43 and one is with a negative 3.43. These are basic equations that you're solving. I don't think there's a need to write all these out for the millionth time. If you're going to solve it with a positive 3.43, you're going to do 3.43 and add 2.34 and come up with 5.77. If you do it with a negative 3.43 and take away, or add actually, 2.34, then you get negative 1.09. The time it took the ball to hit the ground is going to have to be positive, so that one is out. 5.77 seconds for the ball to hit the ground. Lesson 24, still the same title, Modeling with Quadratic Functions. Write the quadratic function that passes through the points negative 2, 36, 0, 10, and 6, 124. To do that, you have to know what the general form of a quadratic equation is. ax squared plus bx plus c. Which one of those is the y-intercept? C, but which one of those points? 0, 10, yes. It's going to be 0, 10. Okay, from that we can get that 10 out of it, and we can now write this. Y equals ax squared plus bx plus 10. If it crosses at positive 10, then you're going to have a positive 10 at the end of your function. Now we go to this point. If we plug in a negative 2 for x, then we should get back a 36. That's why 36 is going to go in place of y. And then we put negative 2 in place of x. We keep our positive 10 in there. And we simplify this as much as we can. Quantity squared of negative 2 is not negative 4. It is positive 4. So we have 4a. Negative 2 times b gives us a minus 2b. And then the plus 10. Move the 10 over with the 36, change the sign, and then simplify. You come up with a 26. That's one equation you can use. We're going to hold that while we go back and do the other one. And we'll do that one in green. If you put in a 6, you get back a 124. That's why 124 goes in place of y. And we have 6 going in for x. Don't forget the 10 that goes in there. Simplify this. We have a 6 squared, that's a 36. So 36a, and then plus 6b, plus 10. Move the 10 over with the 124, change the sign, and simplify. That gives us a 114. And we have this that we can use. Remember, we're finding these two equations so that we can use systems of equations to solve for A and B. But remember what we did yesterday? We rewrote them with the variables on the left and the constant on the right. When you switch equations both sides, you don't have to change the signs. 4a minus 2b is 26. 4a minus 2b is 26. And then the other one is 36a plus 6b equals 114. You have to solve this system of equations. You can choose to eliminate the a's, you can choose to eliminate the b's. What I'm going to do is eliminate the b's. I want a 6b in this spot, so I'm multiplying by 3. And I will get 12a minus 6b equals 26 times 3 is going to be 78. On the bottom, it does not have to change. We have a plus 6b with that one. Minus 6b plus 6b, those are opposites. I can't subtract or I'll end up with a negative 12b. I must add them together. So if I add them together over top of this squiggly mark, then I end up with 48a. These cancel out. And 78 plus 14 is going to give me a 192. Divide 192 by 48 and you come up with 4. So your a value is 4. Plug that back in to one of your original equations. I'm going to use the top one. 4 times 4 minus 2b equals 26. 16 minus 2b equals 26. Move the 16 to the right, subtract, and you end up with a positive 10. So 10 divided by negative 2 is negative 5. Don't forget the answer is the function. So y equals 4x squared minus 5x plus 10.